Okay, so looking at page 3 of review 9 and 10. Peter has a playlist of romantic songs for his dinner date. Baby come back, baby baby, love is stronger, love is sweeter, stronger, I love my baby, in a moment's time, no one like my baby. If he shuffles the playlist, so any of the songs could happen. So my total is, so he's pressing shuffle, it can choose from any of the songs. So there's 1, 2, 3, 4, 5, 6, 7. 7 total songs. But only the songs with baby in the title happen to play. How many ways can the songs with baby play? Okay, don't know why this got cut off. So basically, how many ways, how many arrangements, that is a permutation. And I kind of jumped the gun with that, with putting in 7 as my N. And how many songs with baby in the title? So 1, 2, 3, 4. 4 of them have baby in the title. Okay, so that would be 7 permutation 4, because the order that the songs play in, I would argue, does matter. 7P4. On the calculator, 7 PRB, select 4. 840 ways. 840 different orders that only the songs that have the word baby in the title could be played, given that any of them could be played. Sorry, not given, but knowing that any song could be played, but only the songs with baby in the title are being played. Wow, I'm trying to go through this quick and it's not working out. If he chooses to shuffle the playlist, what is the probability the first song has baby in the title? Okay, that's easy, straight up probability. 4 baby songs, 7 total songs. Great. What is the probability that the second song has baby in the title if you know the first song does too? Okay, I'm going to draw a tree diagram. So the song could either have baby in the title or not. I like to just do 2 branches. I know a lot of people did like lots of branches. I think it's easier to just say if it has baby or if it doesn't, because that's all we really care about. And then the second song, so you could almost like draw a dotted line as like this second set of branches is based on the second song. So first song, second song. When I see a tree diagram almost as columns, it's easier for me to process what the branches actually mean and make sure I don't miss any of the branches that I need to put in. Baby, no baby, baby, no baby. On each branch, I'm going to put the probability that that song plays. So the probability that baby plays, we already got that, 4/7. So not would be 3/7. Second song means there are now 6 songs to choose from, right? Because one song is already played. When you shuffle a playlist, it goes through the songs. It does not repeat songs, okay? At least that's how Spotify works. I believe Apple Music works that way too. In general, shuffling a playlist, you're only going to listen to each song one time. It's just that the order of those songs is random. So if the second song is baby, but the first song was also baby, these all have a denominator of 6. Sorry, I'll put a denominator of 6 because it's all the second song. And then if baby has already played, then there's one less option, 3/6. If baby has already played but we want a non-baby song, that is also 3, right? Because these also need to add back up to 1. 3, 6 plus 3, 6 is 1. And then if baby does not play, then we have 4 left that still have baby in the title. And if baby does not play, then we still have, if 1 without baby plays, then we have 2 more left that also do not have baby in the title. Okay, makes you start to wonder, why would anyone care? So what is the probability that the second song has baby in the title if you know the first song does too. So when we're usually putting probabilities at the end of the branches, these probabilities would be the question would be like, what's the probability that the first and the second song have baby? So then you would multiply this times this, and you would get the probability that the first and the second song have baby. But no, they want to know what is the probability the second song has baby, given you know the first does. So we're only looking at the column of second song. The second song having the word baby in it, given only one piece of information, given this. So given this first branch, what is the probability that baby is played for the second song? It is 3/5. Reduce that, and you get 1/2. And that would be how you look at basic conditional probability from the perspective of a tree diagram. Using counting principles like factorials, permutations, and combinations to evaluate the following. Show all your work, include the principle you use to solve, even if you do it on a calculator. Okay, Miss Aureli, that would be me, loves listening to Nicki Minaj. Her favorite songs are No Frauds, Changed It, Chun-Li, Barbie Tings, Va Va Voom, and Super Bass. On her way to work, she only has time to listen to 5 songs, but she doesn't want to repeat any of them. How many ways can she listen to her Nicki Minaj faves on her way to work? Okay, have you ever listened to music and right before you play a game or right before you do something important, you pick a certain song? Okay, so the order of the songs, I would say as a musician, as someone who loves music, okay, and maybe you agree or disagree, I would say that the way that we play the songs, the order does matter, okay? And if the order does matter, then this would be a permutation. How many total songs? 1, 2, 3, 4, 5, 6. How many can I listen to? 5, 6, P5. I feel like I should be able to do this in my head, but I can't right now. 720. Jack has a baseball game after school. Once he gets home, he wants to play Fortnite. I think, isn't that spelled wrong? Yeah, this is spelled wrong. Sorry. I don't play Fortnite, as if you couldn't tell. But I have had it spelled wrong in this review for like a couple years now, so that is a problem. Anyways, he also has to do geometry homework. He also needs to write an essay and eat dinner. How many ways can he do the things he needs and wants to do before bedtime? Okay, so how many things? Once he gets home, wants to play Fortnite, geometry homework, write an essay, dinner. How many ways can he do the things he needs and wants to do before bedtime? And I would say that is also the baseball game that he has to do. Nope. Once he gets home. Okay, sorry. Jack has a baseball game after school. Once he gets home, he wants to play Fortnite, but he also has geometry homework, an essay, and dinner. All right, that is 4 things that he wants to do, and he wants to do all 4 of them. So the total is 4, the selection is 4. How many ways can he do the things he needs and wants? I'm guessing that the order does matter, right? Because maybe his mom or someone is going to be like, no, you need to write your essay first, blah, blah, blah. So yeah, the order does matter because there is a more desirable order than and less desirable order. Whereas combination, there is no distinction. So we have 4P4, which is 24. Or you could recognize, hey, if my total and my selection are equal to each other, that is just the same as writing 4 factorial. So that would be PRB, also 24. Naomi needs to take care of the cats at the shelter she works at. There are 22 cats. She only has time to bathe 7. 11 of them have already been recently bathed. How many ways can she choose to bathe the cats who have not been recently bathed? Okay, so Naomi needs to take care of the cats. There are 22, but 11 of them have been bathed. So the total is now 11 because she's not going to bathe the ones that have just been bathed. And the selection is, how many of them? Oh, time to bathe 7. I was like, I know there's 7 in here somewhere. Okay, she only has time to bathe 7. I originally planned for this problem to be a combination one. My students argued that it could be a permutation. I would accept either answer, but if we're going off of kind of what we did up here, he's getting everything done before bed, but it does matter the order. She's bathing all these cats. I was figuring, well, they're all gonna be bathed at the end of the day. It doesn't actually matter the order that she bathes the cats in, but I could see where people would think it's a permutation. So I would accept either permutation or combination. The answer key that you're given is permutation because more of my students agreed that it sounded like a permutation than a combination. Okay, and that would be 1,663,200 different ways that she could bathe those 7 cats. Whew. Mr. Punch will be choosing 3 of his top geometry students for the upcoming Honorable Student Award. Is there any difference between those that are going to get the award? Okay, so if 2 people get the award, is there any distinction? No, the certificate is the exact same. It just says Honorable Student. He has 8 students who qualify, so my total is 8. He's choosing 3 students. Each one gets an award. It's not gold, silver, or bronze. It's all the same award. It's called Honorable Student. Therefore, this is a combination. Order does not matter. There's not a clear distinction between the selection, members of the selection. So 856 different ways. And then Ashley wants to make the advanced dance team. The teacher has 4 new slots to fill with 12 students trying out. How many ways can she fill the spots? Okay, to fill the spots on the team, also, order does not matter. Okay, she's not saying, oh, you're first string, you're second string. Okay, no, it's just, I need 2 more people. There are 2 options open. Both are equally on the dance team. Okay, so that is also a combination. 12 people, 4 new slots. So total is 12. Selection is 4. Combination. $495.